Now, come to another interesting result. Let x equals xn. Consider let x equals xn be a sequence of real numbers. Suppose it is a subsequence that converges to 0. Let xnk be a subsequence of x such that this sequence xnk converges to 0. Then prove that x or limit x equals 0. Then prove that limit x equals 0. How to prove this one? X be a sequence of real numbers. Suppose it is a convergent subsequence. If that sequence converges to 0, then limit x is also 0. How to prove? Again, the proof is done by contradiction method. If possible, if limit limit x differs from 0. Limit x differs from 0 means there exists a subsequence xnk of x such that modulus of xnk minus x some greater than or equals epsilon. Here instead of x, here it is 0. Modulus of xnk minus 0 greater than or equals epsilon for all nk, or direct for s, where nk fallen k, and this nk greater than or equals this, s, nk fallen n, k fallen n, and nk greater than or equals k. So it is modulus of xnk minus 0 greater than epsilon means it is modulus of xnk strictly greater than or equals epsilon. Agree. Choose y1 such that this y1 equals xn. This one y1 equals xn. Okay. Come on, then there exists some nk plus 1 greater than nk. Nk is a natural number. There exists another natural number nk plus 1 that should be greater than nk such that modulus of x nk plus 1 minus 0 it is greater than epsilon. That means modulus of x nk plus 1 greater than or equals epsilon. Why? Because of this. Again you can choose another y2 such that what is y2? y2 equals xnk plus 1. There exists some nk plus 2 greater than nk plus 1 such that modulus of x nk plus 2 minus 0 greater than or equals epsilon, that is modulus of xnk plus 2 greater than or equals epsilon. So proceeding like this inductively. Then there exists a subsequence, all of these are subsequences of xn, therefore yn is a subsequence of xn such that this yn, modulus of yn greater than or equals 0 means modulus of yn greater than or equals epsilon naught means the sequence yn does not converge to 0. Okay. So that's a contradiction. Why? What's our statement? The subsequence of xn converges to where? 0. But after this, we get this result. The subsequence of xn does not converge to 0. This is a contradiction to the hypothesis. Contradiction is due to our wrong assumption. Therefore, limit x equals 0. Okay. So this is the proof. Clear? Now, consider another result. Let xn greater than or equals 0. Xn is a xn greater than or equals 0 for all n falling in. For all n falling in. Xn greater than or equals 0 for all n falling in. Also, limit minus 1 power n xn exists. Then prove that secant xn converges. Prove that secant xn converges. Secant minus 1 power n xn, that converges. Why? Because its limit exists. Limit minus 1 power n xn exists means the secant minus 1 power n xn always converges. Minus 1 power n xn converges. Limit minus 1 power n xn exists. It means secant minus 1 power n xn converges. When xn is a sequence of non-negative reals, then secant and if secant minus 1 power n xn converges, then show that the secant xn also converges. How to prove this one? Limit minus 1 power n xn exists. Limit minus 1 power n xn exists means, suppose if possible, limit n goes to infinity minus 1 power n xn equals some L. Suppose it is here. That means for all epsilon is positive, there exists some n following n such that modulus of minus 1 power n xn minus L strictly less than epsilon for all n greater than or equals k. There exists k following. Okay. That means epsilon greater than modulus of minus 1 power n xn minus L. Agree? So, epsilon greater than modulus of minus 1 power n xn minus L. We know that modulus of mod x minus mod y, it is less than or equals modulus of x minus y. This is a non-distinction. Modulus of mod x minus mod y less than or equals modulus of x minus y. That means modulus of x minus y greater than or equals modulus of mod x minus mod y. So from here, this means epsilon greater than or equals modulus of minus 1 power n xn minus mod y. Okay. Why? Because modulus of x minus y greater than or equals modulus of mod x minus mod y. That means epsilon greater than or equals modulus of mod xn minus mod y. Okay. Or this epsilon greater than or equals minus of modulus of minus 1 power xn minus L. This can be rewritten as it is modulus of minus 1 power n into mod xn minus L. Okay. Modulus of minus 1 power xn minus 1 power n into mod xn minus mod L. Clear? Yes. So epsilon greater than or equals modulus of minus 1 power n into mod xn minus mod e. So that equals, it is modulus of xn minus mod e. Why? Because xn with the minus 1 power n modulus is 1. Mod xn, since xn is greater than or equals 0, so modulus mod xn is nothing but xn itself. Mod xn minus mod e. That means modulus of xn minus mod L less than or equals epsilon for all n falling or n greater than or equals some k. That means xn converges to where? Xn converges to mod E. That means xn converges to mod L. That means secant xn converges. So if minus 1 power n xn converges for every non-negative real number is xn, then we can say that the secant xn also converges. Okay, so this depends upon this result. Why? Because modulus of mod x minus y less than or equals modulus of x minus y. Here minus 1 power n, which is common here. Okay, minus 1 power n goes outside. So modulus of minus 1 power n into modulus of mod xn minus mod L. But xn be a sequence of non-negative reals. Mod xn is simply xn itself. So it is mod xn minus mod L. Means finally modulus of xn minus mod L less than or equals epsilon or strictly less than epsilon. That means secant xn converges to where? Mod n. So secant xn converges to any point. That means secant xn is a convergent sequence. Agreed? Okay. Now we are going to a well-known term, that is Cauchy sequence. We know that what is a Cauchy sequence? We already said that, already learned this one, already studied this one. What is secant xn? Secant xn is Cauchy. If secant xn is said to be Cauchy, or secant xn of real numbers is said to be Cauchy, if for all epsilon is positive, there exists some k following n such that modulus of xn minus xn strictly less than epsilon for all n comma m greater than or equals this k. Then xn is the Cauchy. Sequence 1 by n is a Cauchy sequence. Also, we already proved that one. So there is an important lemma. Means every convergent sequence of real numbers is Cauchy. I thought that this is a proved result. Every convergent sequence of real numbers. Convergent sequence of real numbers is Cauchy. Convergent sequence of real numbers. How to prove this one? Every convergent sequence of real numbers is Cauchy. So let secant x equals secant xn. Suppose it is converges to x. Then secant xn is a convergent sequence. We have to show that this xn is Cauchy. Mod xn converges to x means for all epsilon is positive, there exists some k1 following n such that modulus of xn minus x strictly less than epsilon for all n greater than or equals this k1. Okay, whatever may be. There exists some k1 for epsilon by 2. Now, consider modulus of xn minus xn. To prove xn is Cauchy, we have to show that mod xn minus xm less than some epsilon. This is nothing but modulus of xn minus x plus x minus x. You can introduce xn minus x simultaneously. By the property of modulus, it is mod xn minus x plus mod x minus xm. Mod x minus xm is nothing but mod xm minus x. But it is strictly less than epsilon by 2. It is also less than epsilon by 2 for all m greater than or equals k1 equals epsilon. That means mod xn minus xm strictly less than epsilon for all n comma m greater than or equals some k1. Thus secant xn is Cauchy. Means a convergent sequence is always a Cauchy sequence. Okay, so this is another important result that is regarding the Cauchy sequences. Clear?